So if we look at beryllium, beryllium has a 1s2, 2s2 configuration. We do not look at the electrons closest to the nucleus. We're looking at the largest quantum number. In this case, it is shell number 2. If we also look at chlorine, which has 7 valence electrons, the outermost electrons are in quantum number or shell number 3, and we add them all together. So you have 2 electrons in the 3s, and you have 5 electrons in the 3p. When you add them together, that gives you 7 electrons. Again, you can use the periodic chart to shortcut this, or you can figure it out using the electron configuration, looking only for the largest shell number.
I'd like to now talk about ionic bonds and next chapter, covalent bonds. So we have two distinct different types of compounds that have different physical properties, chemical properties, and behave distinctly different from each other. So the first one we're going to talk about is ionic bonding. Ionic bonding is a bond that's formed by trading electrons. Neutral atoms have a valence electron in the outer shell, and in the first column, each one of these has 1 valence electron. Second column, 2 valence electrons, 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons. Everybody's trying to look like a noble gas and have 8 valence electrons. If you look at the Roman numeral on the periodic chart that I've been pointing to, this shows the number of valence electrons in the atom. These outer electrons are the electrons that do chemistry. Hydrogen's valence electron is in a 1s and it has 1 electron. Lithium is in a 2s, has 1 electron. Sodium is in a 3s, has 1 electron. Potassium is in a 4s, has 1 electron, etc. So down this whole group or family, they all have 1 valence electron. If we look at beryllium, its last electron has gone in a 2s and it has 2. Magnesium is a 3s and has 2. Calcium is a 4s, has 2. Strontium is a 5s and has 2. And that again, that group or family has the same number of valence electrons. Now everybody's trying to get the number of electrons to match a noble gas. Noble gases are very stable, and atoms try to achieve that noble gas electron configuration. So lithium has 1 electron in the shell number 2, and if it gains additional electrons, it would need to gain 7 more electrons to have 3 plus 7 to have 10 electrons to look like neon, or it could lose that valence electron and have 3 minus 1 electron and look like helium, so look like 2. So it's easier for lithium to lose the valence electron rather than gain 7 more electrons to look like neon. So lithium has 3 protons. It also has 4 neutrons, just in its nucleus for its major isotope. It has in shell number 1, 2 electrons, and it has in shell number 2, 1 electron. And it's easier to remove the 1 electron and look like helium rather than gain 7 electrons and look like neon. Now, because I have 3 positives in the nucleus and 2 negatives, lithium no longer is neutral, but it is a positive ion. It has 1 additional proton that is not having an electron to balance that charge, and we call this a cation. So positive ions are cations, and we're going to see that metals like to become cations. Nonmetals, on the other hand, like to become anions. An anion has gained an electron. A cation has lost an electron. So let's take a look at fluorine. Fluorine has 9 protons, and in a neutral compound, it would have 9 electrons. It wants to have the same number of electrons as the noble gas, and it's easier for fluorine to pick up an electron, and if we gain an electron, we go negative. So when it was neutral, it had 7 valence electrons, and we can write those electrons around fluorine. And it would like to have 8 valence electrons. So it's missing 1 electron here to be a same electron configuration as neon. And so it likes to gain an electron, and gaining electrons become negative species. Now, lithium and fluoride are then attracted to each other, and a lithium fluoride bond forms. Let's talk about what that looks like. So if we look at the left side, sodium metal comes in individual atoms. Chlorine gas is a diatomic molecule, and they're showing the gas molecules. But when it forms a bond, it makes a crystalline salt. Sodium ions are positive, and they're surrounded by as many negative anions as possible. And every anion is surrounded by as many positive cations as possible. So when we look at a crystalline lattice structure, you will notice each positive is surrounded by as many negatives as possible, and each negative is surrounded by as many positives as possible.